Hey class, welcome to our 2.3 notes on position versus time graphs. Now, today we've already done something like this in class where we were out at the football field and we were graphing our motion up and down the field. Now, we're just going to formalize that a little bit and talk about what different graphs mean and how we can interpret these. So, when it comes to position time graphs, it's really important to get a visual because graphing is a visual activity. So, let's go ahead and start by drawing ourselves a graph, just like this. Left and right looks pretty normal. Now, when it comes to position time graphs, on all of them, no matter what, position goes on the Y, which then puts time on the x-axis. So with this, we're going to label our graph just like this, position and time. And when it comes to position time graphs, it's important that we are always moving right. Because if you're not moving right, that means you're moving left, which means you're going backwards in time, which isn't possible. You also can't be moving straight up and down. That would imply you've frozen in time. So neither of those things are able to happen. So we are always moving right. However, we can move up and down our graph because that would mean I'm moving back and forth on, let's say, the football field like we did for our lap. So we're going to draw a example of a position time graph here where we're going to go up, have a flat line, and then draw it out. And it's important that we have different slopes with this graph. So we have section A here going up, we have section B in the middle, and then we have section C as I go down the side of this kind of hill that we've drawn for ourselves. And each of these are associated with something different that's going on. So with A, where we're going up, that means you have a positive velocity. That means you are moving in the direction that you indicated as positive. For most time, that's to the right or up. Now with the B section where we are flat, that means you have no velocity. Or as more commonly, we'll say you are at rest. When you're at rest, you're not moving. So notice his position at B doesn't change. So he's just kind of standing there. The person, the object, whatever it is, they're just still. Just being still where they're at. And then the final section, C, would be when we are going down. And that is the opposite of up, which means I have a negative velocity. This is either walking backwards or moving backwards or trying to go back to your original position. So this would be like when we're all the way at the end of the football field, we're going back towards that goal line. And on all of these, the important information is the slope. So this is going to be kind of a star important bit here that we need to remember. And it's that the slope of this graph tells me the velocity. So if I were trying to list these in order of fastest to slowest, A would be my fastest line because it's got the steeper slope, then C, and then B would be the slowest because it's not moving at all. So the slope matters. And when you have a slope, you can calculate the slope. And this is kind of more of a math reminder, but when I want to calculate slope, it is equal to my rise over run, or my change in y over change in x, or more formally, y2 minus y1 over x2 minus x1. So on your worksheet, when it asks you, hey, calculate the velocity using the slope, you're gonna wanna find the slope, rise over run, right? How far up do I go every second I'm moving over? And you might have to do a little math in there because you might have to find a point that's 3 seconds. So you're gonna have to do a little division, which is just fine. You just gotta find the slope of that line. So as you work on your graph, just remember all of this is just how an object's moving. Is it moving forward, backwards, or is it staying still?